All right, so here we go. All right, so just like in the warm-up, we did similar triangles, okay? We are looking at similar triangles with right triangles. So the first thing we're going to do is just learn to identify the different right triangles that are there, and then we're going to find the missing pieces, but we're going to identify the parts first, okay? So first thing I want you to do is, looking at this diagram here, I want you to put 1 tick mark in this angle. I want you to put 2 tick marks in this angle because they're not equal. This is not a 45, 45, 90. It's not a 30, 60, 90. This is just a plain old regular right triangle. Okay. So what we do is when we have a right triangle similarity, you have to take the altitude that's drawn from the vertex. Okay. Okay. All right. So what you're going to do is you're going to take your right triangle and you're going to draw the altitude. Remember, the altitude is just the height of your triangle. So you're going to draw the altitude. What happens is the altitude splits the hypotenuse into 2 pieces. So now I have 2 different right triangles. So not only did I have the big triangle, the ABC, now I have these 2 smaller right triangles, altogether giving me 3 right triangles, and they're all similar to each other. Okay, so if I take, what I'm going to do is redraw the big triangle. So I'm going to redraw the big triangle here. That's terrible. That's angle B, angle A, and angle C. So this gets 1 tick mark. This gets 2. And I'm going to fix that. Okay. Then I'm going to draw the medium triangle. So my medium triangle, basically, it's like French fries. You get small, medium, and large. There's B, there's A, and there's D. And then I'm going to redraw the small one. So there's B, there's D, and there's C. So now triangle ABC has 1 tick mark, 2 tick marks, and then the right angle mark. The medium triangle has a right angle mark, and I know that this angle A is 1, just like this angle A is 1. So that means angle B has to be 2. In the little triangle, this is my right angle. Angle C has 2, so this angle C gets 2. So this angle B is 1. 2. So now we're going to identify which 3 triangles are similar. Well, I know they're all similar, but if I don't name them in the right order, then it's not going to be right. They have to be in the same order. So I'm going to start with the largest triangle. So my largest triangle is ABC. So ABC. So notice that the angle A has 1 tick mark. Angle B is the right angle, and angle C has 2 tick marks. So it's similar. So now I'm going to look at the second triangle. Well, if I started with 1 tick mark, I have to use the angle with 1 tick mark, which is A. Then I have to go to the right angle, which is, in this case, D. I forgot to label that. That's a D. And then 2 tick marks is B. Then you do the same thing with the tiny triangle, starting with 1 tick mark, which is B. The right angle is D, and the 2 tick marks is C. Okay? So now I know ABC is similar to triangle ADB, which is similar to triangle BDC, because they're all in the order of 1 tick mark, right angle mark, 2 tick marks. Okay? So now we're going to do the same thing again with this one. So I'm going to put 1 tick mark here, and it doesn't matter. You can put 2 here and 1 here. It's just whatever. Okay. So if I have the largest triangle, so this is angle R with 1 tick mark. Angle Q has the right angle mark. Angle P has 2 tick marks. And then I'm going to do PQS, which is my medium triangle. So this is angle P, this is angle Q, and this is angle S, where now this is the right angle. This has 2, so that means Q is going to get 1. And now the small triangle as well. So my right angle is at S. R is 1. And then I have Q, which is going to be 2. So if I start with the big one, R, P, Q. R, P, Q. So the order I went in this time, 1 tick mark, 2 tick mark, right angle. So this is 1, 2, R. So now I look at the medium triangle, and I want to do the same thing. 1, 2, R. Q, P, S. Q, P, S. Then you do it one more time so that you get the itty bitty triangle. So 1, 2, R. So 1 tick mark, 2 tick marks, right tick mark. So R, Q, S. We're going to go down here and we're going to find these missing pieces by separating the triangles, but we only have to do it twice, okay? So I'm going to do the largest triangle here. So if I look at this larger triangle, I see that this is 9, or this is the 90. This side is 9. This side, which is the hypotenuse, is 15, and this side is 12. I'm looking for X. So what I'm going to do is just use that little tiny triangle right there. So if I use the little tiny triangle, that's horrible. That is 9, and that is X. So if I go back and think about how I was doing the warm-up when I'm setting up my proportion, first I need to make sure I'm putting my angle marks in here. I guess that would probably be the first helpful thing. So 1 tick mark, 2 tick marks, 1, 2. So this, since the little tiny triangle, that's a 1, so that's a 1. So that means this angle here has to be a 2. So since this is 1 tick mark, this is going to be 2. So I'm just going to compare these two. All right. So if I'm looking for X, it's between the 2 and the 90. So I have to pair it with 12 because it's between the 2 and the 90. So this 9, which is the hypotenuse, has to pair with 15 because it's the hypotenuse. And then I'm going to cross multiply. 15x equals 108. Divide by 15. And I get 7.2. So now same thing here. I'm going to redraw the big triangle. So starting with the big triangle, and these are really terrible triangles. So this is 11.2. This is 23.8. And this side over here is 21. And this is going to have 1 tick mark, and this will have 2. So 1 tick mark and 2. And I'm going to compare it to the smallest triangle again. So if I redraw the smallest triangle here, this is 11.2. This is X. That's 90. This is 1. So that one has to be 2. Set up your proportion. So if I'm looking for X, X is between the 90 and the 2. So it's going to pair with 21 because it's between the 90 and the 2. Then I'm going to use the hypotenuse. So I have to pair it with the hypotenuse of the other side. Cross multiply these two. Divide by that one. So cross multiply and divide, and we get 9.9. All right. So now, if we're looking for X here, I'm going to do the tiny triangle and the large triangle. So if I redraw the large triangle, So this is 24, this is 7, this is 25. And I'm going to put 2 tick marks here, and I'm putting 1 tick mark in this tiny one just simply because nothing else is going to fit. So I'm going to put 2 and 1. So there's the large triangle. Now I'm going to redraw the tiny one. So the tiny one, that's 1. So that has to be 2. This is X, and this is 7. So if I set up my proportion, if I'm looking for X, X is between the 2 and the 90, so I have to pair it with 24 because it's between the 2 and the 90. Then I'm going to use the hypotenuse of the small, so I have to use the hypotenuse of the big. And when I cross multiply and divide, I get that X is 6.72. So here we go. All right, the second part. Okay, you have done what's called arithmetic mean or average, where you add them up and divide by how many there are. So now we're going to do geometric mean. The geometric mean is proportional. Okay, so our geometric mean is going to be represented by X in this proportion. And we're going to find the geometric mean between 2 numbers. If I was just looking for regular old mean, I would say A plus B divided by 2. But geometric mean, the geometric mean will be in both of your fractions. It'll be the numerator of one fraction. It'll be the denominator of the other. The other 2 numbers just go in the other 2 spaces. And it doesn't matter which is which. Okay? As long as you have an X in the top and an X in the bottom, or a geometric mean and a geometric mean, so that when you cross multiply, you get X squared equals AB. And then you have to take the square root of both sides. So the geometric mean is the square root of the product of 2 numbers. So now we are going to find the geometric mean of these 3 pairs of numbers. So all you have to do is set up a proportion, put the geometric mean in the top and in the bottom, and put the other 2 numbers in the other 2 slots. Then you're going to cross multiply, take the square root, and make sure that when you take the square root of both sides, that you are simplifying your radical. So remember, we need it into 2 different. So this is going to be the square root of 36 and the square root of 5, because remember, the first number has to be a perfect square from our list of perfect squares. So this would be 6 square root of 5. That's terrible. Okay. Same thing here, 2 numbers, set it up. Proportion, geometric mean, 16 and 28. Cross multiply. Take the square root of both sides. So the square root of 448. So if I split it into 2 numbers, this is 64 and 7. So that would be 8 square root of 7. And yet, do it again. You do this when you have 2 numbers and they want the geometric mean. You're just going to do this every single time. You set up your proportion, put the geometric mean in the top and in the bottom, put the other 2 numbers. Cross multiply. Take the square root of both sides. So if I have the square root of 600, well, I know 600 is 100 times 6. The square root of 100 is 10. So my answer is 10 square root of 6. All right, so now let's apply the geometric mean to the actual parts of a triangle. So the first one is called the altitude theorem. The altitude theorem means you have a right triangle and you draw the altitude. So when you draw the altitude, it splits the hypotenuse into two segments. So I'm going to call the geometric mean X. I'm going to call this part of the hypotenuse A. I'm going to call this part of the hypotenuse B. So my thing is circle the geometric mean. That way it tells me, it's a reminder to me that that is the part that gets repeated twice. So when I set up my proportion, I know that the geometric mean is what goes in the top and in the bottom. And it pairs with the two parts that the hypotenuse was split. So those are the two numbers. So that means if you know the two pieces of your hypotenuse after you draw the altitude, you can find the height of your triangle by doing the geometric mean. So if I multiply A and B together, so x squared equals AB, therefore x is the square root of AB. So if I multiply A and B, the two parts, and take the square root, that is the height of my right triangle. First thing I want to do when I get to a problem where I'm doing this is I want to circle the geometric mean, and then I'm going to draw lines to the two parts that I need for that geometric mean. Okay, so when I set up X is the geometric mean, it pairs with 8 and 12. Now we're just going to do it exactly like we did the others. Cross multiply. X squared is 96. Take the square root of both sides. X is 4. Square root of 6. Because 96 is 16 times 6. And when you take the square root of both, you get 4 square root of 6. Okay. All right, next, X is my geometric mean. It pairs with the two pieces. So it pairs with 5, and then it pairs with this piece, which is 32, because the whole thing is 37. Since this piece is 5, that means the leftover piece is 32. So now, and you're going to want to watch for that when you're doing the assignment. So X is my geometric mean, and it pairs with 5, and it pairs with 32. So X squared equals 160. Take the square root of both sides. X is 4 square root of 10. Number 10 looks a little bit different because this time the geometric mean is not X. 18 is our geometric mean. It still pairs with the two pieces. It doesn't matter if they give you the geometric mean or if they ask you to find the geometric mean. The altitude is the geometric mean. So when you set up your proportion, 18 is what goes twice this time because that is your geometric mean. And then X and 15 are the two pieces that it pairs with. So when I cross multiply, I get 15x equals 324. Divide by 15. X is 21.6. Oops, 21.6. All right, last one. This one is a little bit tricky. 21 is my geometric mean. So when I'm setting up this proportion, I know 21 is what's going to go twice because that is the geometric mean. Now, 21 pairs with the two parts of the hypotenuse. 30 is one part. The other part is this right here, which I know is x minus 30, but I'm going to call it a. And the reason I'm going to call it a is because isn't 30 plus whatever that piece is going to be our x? So what I'm going to do is say, okay, x is 30 plus a. So I'm going to find out what a is so I can just plug it in. It's just much easier that way. So 30a equals 441. Divide by 30. A is 14.7. So if I add 14.7, then I find out that x is 44.7. So the whole hypotenuse is 44.7. Otherwise, I would have had to have done 30 over 21 equals 21 over x minus 30. Then I would have had to distribute, created a whole equation, and had to solve for x, when in reality, I could have just found that piece by assigning it a variable. I could have called it y, I could have called it z, whatever. I'm just going to call it a, because that's what we started calling it at the top in our beginning.